With generics out of the way, let's dive into the next, more advanced feature, and that would be decorators. Decorators are a feature which can be very useful for meta programming. Now, what does meta programming mean? It means that you typically won't use decorators that often to have a direct impact on the end users of your page, so of the users visiting your page, but instead decorators are a particularly well-suited instrument for writing code which is then easier to use by other developers. Now that might sound strange, but you'll see what I mean throughout this module. In the end, it all comes down to the fact that unlike with other code snippets, let's say when we add an event listener, we can easily write code which have a direct impact on the users of our page. If we register a listener on a button and we show an alert after the button gets clicked, then the user visiting our page immediately sees something. With decorators, we don't typically work on that, but instead we can, for example, guarantee that one of our classes gets used correctly, or a method in a class, or we do some hidden transformation, stuff like that. So in detail in this module, we'll see what exactly decorators are about and why we would use them. We will, of course, use them, and you will learn about the different types of decorators TypeScript supports. And we'll see a couple of examples that should make it clearer which role decorators fill and why they can be useful. For that, attached you find our good old starting project. I already started the server with npm start and the TypeScript watch process with tsc-w. And the very first thing we need to configure there is in a tsconfig file. Make sure your target is set to ES6. And then, if you scroll down, make sure that you add this experimental decorators line here. And add a comma in front of this, and then you can auto-format to format this all correctly. This is important, otherwise you won't be able to use decorators in your project. So make sure you tweak your tsconfig JSON file appropriately. And with that, we can dive right in and write our first decorator here in the app.ts file. And I want to start with a decorator we can add to a class. Now, decorators in general are all about classes, but this is a decorator which we will add to the class as a whole. For that, let's say we have a class, person, a very trivial class, where we have a name, maybe with a value of max pre-initialized here, where we have a constructor function where I just log creating person object so that we see that this is executed. And then, of course, we can create a new person here with the new keyword like this. And if we want to, we can of course log this created person. And this should hold no surprises. If we save all of that, it compiles without errors. And if we visit our page then on localhost 3000, in the JavaScript console, we see creating person object, which is coming from the constructor. And we of course also see the person itself here. Now there, in this example, we got no decorators involved. Let's change this. At the top of the file, let's add a decorator. And a decorator, and that's really important to understand, is in the end just a function. A function you apply to something, for example, to a class, in a certain way. So let's create a function here with the function keyword, and I will name it logger. Now this is a function. The only special thing here is that I start with a capital character. This is not a must do, by the way. You don't have to use a capital starting character. You can use a lowercase one as well. You just see a lot of decorators out there in libraries which you might use that use uppercase starting characters, and therefore I'll do the same here. So the logger function here is a function, and we can apply this as a decorator, as it will turn out. Now let's add a console login here, logging, so that we can see when this function runs, because I will not call it directly. Instead, I want to add it as a decorator to this class. And we do so by adding an @ symbol here in front of the class, and then our function here, just like this. Now, a couple of special things here. The @ symbol here is a special identifier TypeScript sees or recognizes. And then the thing directly after the @ symbol should point at a function, not execute it, but point at it, which should be your decorator. Now here you see that logger then accepts too few arguments to be used as a decorator here. So the good thing is TypeScript understands that I want to use it as a decorator here. The bad thing is we don't pass enough arguments. And indeed, decorators receive arguments. How many arguments depends on where you use the decorator. Here, for a decorator we add to a class, we get one argument, and that's the target of this decorator, so to say, which is our constructor function. So we can say we get a function here as an argument in the end. We could also name it constructor, because in the end we will get our constructor function of this class, or whichever class we add this decorator to, as an argument. Now let's also console log that so that we can get some insight into this constructor argument here. And let's save this. And as you see, it compiles without errors. And if we now have a look at our output, we see the old code from before, but we also see the logging output and this constructor function being logged. Well, we actually see the whole class here, but classes in the end are just syntactical sugar over constructor functions. Please also note that our decorator output, logging, and this class or this constructor function log here is printed first before we see creating person object and our person object. Because indeed decorators, and that's really important, decorators execute when your class is defined, not when it is instantiated. You don't need to instantiate your class at all. We could remove that code for instantiating the class, and we would still get that decorator output. So the decorator runs when JavaScript finds your class definition, your constructor function definition, not when you use that constructor function to instantiate an object. That's really important to understand. So this is our first decorator. It's not the only way of how we can create a decorator though. Besides creating a decorator like this, we can also define a decorator factory, which basically returns a decorator function, but allows us to configure it when we assign it as a decorator to something. To show this, let's convert this function here into a factory. For that, I will grab this constructor argument and remove it, and instead in here I will return a new anonymous function which takes that constructor argument and which then holds this logic which I want to execute inside of the decorator. So I move that in there. So now we have a function that returns a new function. So now when we want to apply this decorator, we have to execute it as a function here, so that we execute this outer function and we attach the return value, which is this inner function, which is our valid decorator function, as a decorator to class therefore. Why would we do that? Because now here, for example, we could accept a log string here, which is a string, any argument of your choice, and as many arguments as you want, and pass a value for that in, logging person, and use that inside of our decorator function. So that here, instead of showing that standard logging text, we show our log string. So now we can customize the values the decorator function uses when it executes with our factory function. We now call our decorator here because we're not executing the decorator function, but we're executing a function that will return such a decorator function. And the advantage just is that we now can pass in values which will be used by that inner returned decorator function. So if I now save that, we see the old output but with our custom log string here. So using decorator factories can give us more power and more possibilities of configuring what the decorator then does internally. Now, with the knowledge about factory functions or factory decorators, we can do quite interesting stuff. We could create a new decorator factory with template, for example. And there I expect to get a template, which should be some string, and a hook ID, which should also be a string. And then here I return my anonymous function, which is the actual decorator as you learned, because again I have a decorator factory. And in there I want to render some template, which should be some HTML code, into some place in the DOM where I find this hook ID. So now we can go to index.html and add such a place so that we can see that this works. We can add a div here with an ID of app maybe. And then in app.ts, instead of logger, I add with template. Let's pass an empty string as a first argument for now and app as a second argument. So this ID I assigned to the div here. And now inside of that inner function, so our actual decorator, inside of this decorator function, I want to reach out to the element, to the hook element with document get element by ID. For the hook ID, we're getting here as an argument. And if hook L is a thing that exists, then I want to access its inner HTML and set this equal to template, let's say. A very simple setup, of course, but this should do the trick. Now, I'm not interested in the constructor, and to tell TypeScript that I'm not interested here, I can add an underscore as a name, which basically signals to TypeScript, yeah, I know I get this argument, but I don't need it. I have to specify it though. So with this underscore, I tell you that I'm aware of it, but that I won't use it. Because all I want to do for now is I want to render this here. So now when we add with template here we could add a h1 tag, my person object like this, also close it. And if we now save that, it compiles without errors, and indeed, here you see this was rendered on the screen. And this hopefully shows you the power you have with decorators. You can build really advanced decorators like this one, which all of a sudden does some magic behind the scenes. And that is what I mean with meta programming. We add some logic here, which we could expose if this would be a third-party library we share with our users. We could expose this as part of the library, and anyone who uses our library can import this decorator function and add it to a class to then magically render some content all of a sudden. And of course, you're not even limited to that. If you would want to output the name, which is part of the class when it gets instantiated, you can do that as well. We get our constructor function here after all. Now what we can do with that is we can create a new person here by calling our constructor, because that is our constructor function here after all. Let me convert this to any so that TypeScript allows this and doesn't think it's a normal function. And then we could go to our hook element and query for a h1 tag, which we of course in practice will not always have, but for demo purposes, I assume we will always have one here. Whoops, and I should also close the h1 tag down there now that I see it. And then here, with an exclamation mark, again, assuming that we always find a h1 element, we can set the text content equal to p.name. And if I do that and save this, now I output the name, which is part of the object here in the template. So this is something you can do, and of course you can write way more elaborate decorators than I'm doing it here. Consider Angular, a very popular framework that uses TypeScript. They use decorators, like this component decorator, to allow you to pass in an object where you specify things like the template for this component and the selector in the DOM where this template should be rendered. This is relatively close to what we defined here, a template and then a place where it should be rendered. Now, needless to say, the Angular decorators are of course way more advanced and elaborate than our basic decorator here. Nonetheless, the core idea is the same. Angular gives you the decorators here so that you can specify some HTML code which can be connected to your component class that will be rendered to the DOM when this component gets rendered. Now, in case you don't know how Angular works, that's not a problem. You just have to understand here that it works with classes and decorators, and then it does basically what we did here. So that's one of the things you can do with decorators, or specifically here with decorator factories, because that allows us to pass in that extra config which we need here. And that's also what I meant with meta programming. We're creating things, we're creating decorator functions which you might say have some impact on the end user. In the end, we do render something on the screen here, but we do that with a tool which we expose to other developers, because this decorator is such a tool which other developers have to use by adding it to a class in this example. Otherwise, this would do nothing. So we provide extra utilities to developers, which the other developers can use to, for example, conveniently render something on the screen for a given class. That's the same thing Angular does here in a more advanced way, and it is something decorators are perfect for. So we now saw a more useful decorator. I want to conclude this very basic introduction to decorator with another important thing you should know. You can add more than one decorator to a class or anywhere else where you can use a decorator. So let's also add the logger decorator here, for example, like this. If we save that, you see it compiles without errors, and indeed we see the log message here as well. This just leaves one important question: in which order do these decorators execute? Well, for that to find out, let's throw log messages into both. We do have a log message in the logger, obviously. Now let's go to the decorator function, so to the inner function of with template, and say rendering template, for example. And now let's see in which order these functions are executing and in which order these log statements are printed. And we see rendering template runs first, and then we got the logger output. Now what this tells us, of course, is that they execute bottom up, the bottommost decorator first, and thereafter the decorators above it. With template runs first, then logger executes. And important, I'm talking about the actual decorator functions. The decorator factories here run earlier. If we have logger factory here, and we have the same log in the template factory, so there I say template factory in my log, you will see that there actually the logger factory runs first, and then we got the template factory. And that makes sense because in the end, even though we got this at symbol here I'm executing a function, and we're doing the same here. And of course, regular JavaScript rules apply here, and this function execution happens before this function execution, which is why we see the logger factory before we see template factory. So the creation of our actual decorator functions happens in the order in which we specify these factory functions. But the execution of the actual decorator functions then happens bottom up, which means the bottommost decorator executes first, so this decorator function, and thereafter the decorator above that executes. It's just something you have to know. With that, we got a solid base knowledge about decorators, and you also saw a more advanced decorator, which hopefully also gives you a first impression of why decorators can be useful, especially if you also think about frameworks like Angular. Now let's see to which other places, besides classes, we can add decorators and what we might be able to do there. Now, before we explore more useful use cases or scenarios for some decorators, I want to briefly show you all the other places where you can add decorators. Well, obviously, we can add decorators to classes, but there are more places where we can add them. For that, I'll create a new class, because we need a class for any decorator we want to use, but we don't have to add all decorators directly to the class. Let's say we have a product class here, and in the product class we have a title maybe, which is a string, and we can assign a value here with the constructor. Of course, we could also use the shortcut and do it all in one step in the constructor, as you learned earlier. Here I'll take the longer route. We can have a method there, get price with tax, and for that I expect to get a tax rate, which is a number, and for that to work we should also store a price here, price property, which we also get as part of the constructor. Again, we could use the shortcut here, but I'll do it like this. And then in this method, I will return this.price times 1 plus tax, so that we have this utility method. And we can also add a getter and a setter if you want to. For example, we can add a setter for the price here, where we get the value, which should be a number, and where we control that we can only set certain values. Now, to make this work, I'll rename price up here to underscore price and make it private actually, so that we can't directly reach it. And here I will set this underscore price, and here I will use this underscore price. And with these changes in the setter, we can set this underscore price equal to the value we get, but before we do so, we can check if value is greater than 0 so that we don't accept negative prices. So with that, we only set the price if it's greater than 0, otherwise we don't do anything. Indeed, we could throw an error in the other case. Invalid price should be positive. So that's something we can do. Now we have a class with two properties, with an accessor, and also with a method here. And this method has a parameter. Now to all these things we can add decorators. And let's start with a good old friend, a log decorator. Here I'll name it log to not clash with logger up there, because this log decorator will not be added to a class and therefore it will get different arguments. It will get arguments though, and which arguments a decorator gets depends on where you add it, which is why I can't reuse logger, because that was fine-tuned to only work with classes. Now here I don't have a decorator factory actually, I just have the decorator function like this, but still, which arguments this decorator function gets depends on where we use it. For example, we can add a decorator to a property. Here I can add log like this, and if you add a decorator to a property, the decorator receives two arguments. The first argument is the target of the property, and for an instance property like this one, which we call on an instance if we work with it, this will be the prototype of the object that was created. If we had a static property here, target would refer to the constructor function instead. So here I'll say any because I don't know exactly which structure this object will have. The second argument we get is the property name, simply. That could be a string here. Could of course also be a symbol. We don't know what we use as a property identifier. And then here I will log property decorator so that we can see when this runs. And I want to console log target and also property name so that we see what's in these two values. With that, if we save that, it compiles without errors. And if we go to our server, we see property decorator gets printed down there. And this is our output we get. We see here, that's the prototype of our object because we're not seeing title and price here, but we do see get price with tags. And indeed, methods are registered on the prototype of an object. So that's the prototype of our object. And we see title over here on the right. That's the property name we're working with. Now, when exactly does this logger execute though? Well, as you can tell, since I never instantiate any product, it executes basically when your class definition is registered by JavaScript. So it executes when you define this property basically to JavaScript as part of your class here, as part of this constructor function, which is created here in the end. This is when this property decorator executes. Now, besides properties, you can also add decorators to accessors. And there I will create a new decorator function because this will now receive three arguments, log2. It will also get the target, which again is either the prototype if we're dealing with an instance accessor, or if we're dealing with a static one, it will be the constructor function. So we don't know, it will be of type any. Then we'll have the name of the member we're dealing with. So the name of the accessor in the end. And we'll also have the property descriptor here, which will be of type property descriptor. That's a type built into TypeScript. So in there, let's log accessor decorator. And then I will also console log the target here. And then maybe new lines to make that more readable in the output, the name, and also the descriptor. Now let's add log2 to the setter here, like this. And let's see what we get. If we save that, you see down there, we get the accessor decorator, which executes here. We got our prototype again, the same as above for the property. Then we got the name of our accessor, price in this case, not underscore price, so not the property with which it deals internally, instead really the name of the accessor itself. And we got a property descriptor here, where we see that a setter function is defined, for example. A getter function is not, because for price, I only have a setter, no getter. And we see that it's not enumerable, but that it is configurable, so that we can change this definition here, for example, that we can delete it, and so on. This all exists, and this is how we can add a decorator to an accessor and what we then can access inside of this decorator. Now, besides properties and accessors, we also got methods, and we can add decorators to methods. So here I'll add log3 and add that to my method down there to get price with text. And now the question, of course, is which arguments does such a method decorator receive? A method decorator also receives 3 arguments. The target again, which if it's an instance method is the prototype of the object. If it's a static method, the constructor function, just as before. Then the name of the method here, so string or symbol actually, and also the descriptor at the end, property descriptor. These are the 3 arguments we get here, and you see these are the same arguments as on our accessor. So indeed we could also reuse this, but I will create a new one so that here I can print method decorator. Now with that, if I save this executes, and you see here our method decorator executes. And then here we get our prototype, same object as before. We get the name of the method here, and we get this descriptor of this method here. So the very same behavior as before, basically, just the descriptor is a little bit different since it's a method descriptor and not an accessor descriptor. We got a value and a writable property here. Previously on the accessor descriptor, we had get and set, but that's just a JavaScript difference, nothing TypeScript specific. So here we do have our third decorator function, which we now added to a method. The last decorator we can add is to a parameter. So let's do that now. For that, I'll create one more function here, log4. And I want to add log4 to this one parameter I'm getting here, tags. And you could add one to every parameter you get, of course. You don't have to, but you can add them independently to any parameter you want to add a decorator to. Now, what does a parameter decorator get as arguments? Well, it gets the target, same as before. The next argument we get is the name, and not the name of the parameter, but the name of the method in which we use this parameter. So basically the same as in the method decorator thus far. But the last argument is different. This is now not the property descriptor, but instead this is the position of this argument. So the number of the argument. Here, for example, this would be the first argument. So now again, let's copy that here and put all of that into log4, parameter decorator, and let's output position here as well so that we can see what's in there. If we now save that, we see our parameter decorator up there, not the very last output because execution order is different, but we see our parameter decorator here, and then here we got the prototype as before, we get the name of the method where we use this parameter, and then the index of that argument, and that starts at 0, so the first argument has a number of 0 here, an index of 0. And that's our parameter decorator. So these are all the places where we can add decorators in TypeScript, and we can do various things with them. Now I will show you a couple of examples in this module here, and I'll also show you libraries or frameworks that make heavy use of decorators, and I'll show you what they do with decorators to give you an idea of the power that decorators can have. Before we dive into more examples, let's understand the order in which decorators run though. And here it's important to understand that, first of all, they're all running without us instantiating this product. Or in other words, if I create a product here with new product, book for $19, and I create another product here, book 2 for $29, this compiles without errors, but my decorator code here doesn't run more often. So it's not the instantiation of this class that matters. All these decorators, no matter if it was a property decorator, a method decorator, an accessor decorator, or a parameter decorator, they all executed when you defined this class. And that's important to understand. These are not decorators that run at runtime when you call a method or when you work with a property. This is not what they do. Instead, these decorators allow you to do additional behind-the-scenes setup work when a class is defined. Back to that metaprogramming concept I explained earlier, right? That's the idea behind decorators, or that's their core use case. They're not event listeners you add to something so that when you work with a property you can run some code. You can make something like that work with decorators actually, but by tweaking and editing something behind the scenes. But the decorator itself really is just a function that executes when your class is defined, when your method therefore is registered and so on, and you can then use the decorator to do some behind the scenes work, to then set up some code that should run whenever this is called, to add extra metadata or store some data about a property somewhere else in your project or in your library which you're creating. This is what you can use decorators for, and that's also the pattern you'll kind of see when I now show you these examples of what you could build with decorators. They're adding extra functionality behind the scenes, which then sometimes can execute when you do something with your class or with your method, but which can also do totally different things. That's also important for our person example from earlier with the with template decorator. This does not add this template whenever we instantiate a person here. It does add it whenever we define this class. We would have to add extra logic inside of our decorator function to change this behavior, and to maybe just store this template in some other data structure of our project, which we then tap into whenever we do create a new person here. So that we basically just set this up when we define the class, but we then just store it behind the scenes internally, and we can then use it when we want to use it. Right now, we always render this when we define this class, not when we create a new instance. This is how decorators execute, and as I said, now I will show you a couple of examples where we take advantage of decorators in general and of their execution time to do some nice things with them. In order to do more advanced things with decorators, you have to know that some decorators, for example class decorators, but also method decorators, for example, actually are also capable of returning something. Now, I'm not returning anything in any decorator. I'm not talking about the decorator function which gets returned in the decorator factory. I really mean a return value inside of the decorator function, and we don't have any such value anywhere. Now, in this with template function, in this with template decorator function, I should say, we could add such a return value. And what you can return and what TypeScript is able to use depends on which kind of decorator you're working with. Here, we're working with a decorator that gets added to a class. And in such a decorator function, you can return a new constructor function which will replace the old one. So which will replace the class to which you added the decorator, you could say. So here we can return a new function, a new constructor function, or simply return a new class in the end, because a class, the class keyword, allows us to use this syntactic sugar to create such a constructor function. And the class I create here doesn't need to have a name, but we can and we should extend the constructor we're getting here. So what I'm doing here now is in my decorator function here, I'm returning a new class, and again, keep in mind, that's just syntactic sugar for a constructor function. So I'm returning a constructor function in the end, which is based on the original constructor function, so that I keep all the properties of my original class, of my original constructor function. We don't necessarily have to do that, but I don't want to lose my properties here, so I will do it. And then in here, we can add new functionality. For example, and now I'll have to change some names here, I can add a new constructor function in there, and to avoid confusion, I'll rename the constructor I'm getting here. So the class on which I added this decorator, I'll name this here original constructor, and copy that all over here. And now inside of this constructor function here, I have to call super to call this original constructor function from inside of it, because if you add a constructor function in a class that extends another class, which is in the end what we're doing here, then you have to call super. And now in here you can run any logic you want. And for example here, we could move this template rendering logic here out of our decorator function into this new constructor function we're returning here. So again, really keep in mind that we're creating a class here, which in the end just creates a constructor function with this logic in it. So now what I'm trying to do is I try to replace the class, the constructor function to which we added our decorator, with a new class, with a new constructor function, where I still execute the old logic, but where I also add my own new logic. And therefore now the template should actually only be rendered to the DOM if I really instantiate my object here, and not all the time when this decorator function is executed, which, as you learned, happens as soon as we define the class. Now, a little tweak here, I don't call my original constructor in here anymore. Instead, we can just access this dot name to get the name property value of the instance we are creating. Now, we got a little complaint down there regarding the types not being correct. To fix that, though, we can turn our decorator function into a generic function where we get a type and set this as the type of original constructor. And now make clear that this will actually be basically a constructor function. And we can make that clear by assigning a special type, an object type, where we set a new property. This is a reserved name, of course, but it tells TypeScript that in the end this will be an object which can be newed. So that will be a constructor function, a function we can call with the new keyword to generate a new object. And this new function, this new method, which the object T is based on will get any amount of arguments. So I'm using REST parameters here to accept as many arguments as you want, so that we're really flexible regarding the arguments that can be passed to the constructor of the class we're trying to change. And the new function will then in the end return an object here. Now I should also just copy that definition of the REST parameter to my constructor here, so that this constructor is also capable of accepting all the arguments we might be getting, so that we can basically instantiate person with any arguments we want to pass in here, with any arguments we might also need here in the original constructor function. And with that, the only problem we'll face is that we don't know that such a name property exists, and correctly so, we don't know to which class we'll add this with template decorator. So we don't know if there will be a name property on the class we added to. But we can fix this by simply telling TypeScript that the object T is based on, so our original constructor function, will not just produce any object, but actually will produce an object with a name property which will be of type string. And that is correct. Our with template decorator is added to a class which will have a name property. If I would comment this out, we would get an error, because now we would try to add this decorator to a class which does not fulfill this criterion, but here this does fulfill it. Now I get an error here when I try to compile this because I'm not using args here. We can change this to an underscore to tell TypeScript that we know we don't use it and that we want to ignore this. This is a valid parameter name. It's just a special name which TypeScript takes as a I get it, I need to accept it, but I won't use it parameter. And with that, it all compiles, and if we reload, you see, we still see Max on the page here. The interesting thing just is, if we now remove that code where we instantiate person, if I comment this out, so that I just defined a person class, but I never instantiate it anywhere, you see as it reloads, we don't see Max on the screen. All the decorators still execute, but we don't render anything to the screen anymore. And the reason for that is that we now enhanced our decorator here even more by taking advantage of its feature where we can return a new value, or in this case, a new constructor function in the case of the class decorator. This is a new constructor function, or a new class, which, as I explained, is just syntactic sugar for the constructor function. And this constructor function, therefore, replaces our original class, our original constructor function. Now, since I call super in here, we save the original function. We save the original class. So everything we initialize here basically still happens, because I do that in my replacing constructor as well, and I extend the original class. So we save everything that was in the original class. You don't have to do that, but I am doing it here because I don't want to lose that original data. But behind the scenes, I replaced the class with my new custom class here, and that allows us to add extra logic that should run when the class is instantiated. And now all of a sudden we are able to add logic that does not run when the class is defined, but when the class is instantiated. And this therefore should be a great first example of the full power you can unleash with decorators if you really understand what you can do with them. And you cannot just define them as functions, and you cannot just define them with factory functions. In some decorators, like the class decorator, you can also return something to replace the thing you added the decorator to, in our case the class, with a new class that can implement the old class, but also add its new custom logic. And with that, if we comment this back in, we again render max to the screen with our own class that replaces or that extends and replaces the old class. We saw how we can build quite amazing things with decorators, decorator factories, and then also by utilizing the return values of decorators, which in the example of the class decorator allows us to basically replace the class we added the decorator to with a class that is totally different, that builds up on the existing class, like in our case, and that therefore might add some functionalities. Now, you can return values in other decorators too, but not in all of them. Or not in all of them, the return value is respected. Now, decorators where you can return something are the decorators you add to methods and the decorators you add to accessors. So here on the setter, log2 and log3 on the method, these two decorators, log2 and log3, these also could return something and TypeScript would use it. The decorators on properties and on parameters, of course, also can return something, but TypeScript will ignore it. So return values are not supported there or are not used, to be precise. Now, what can you return on log3, so on method decorators, and on log2, so on accessor decorators, though? You can return a brand new property descriptor. Log2 and log3, which are the two decorators I'm talking about, right? Log2 and log3, both get the descriptor of the property, of the method, you could say, they are attached to, because an accessor is kind of like a method. You have a function that gets executed there. Now, the property descriptor is a JavaScript thing, as you know. If we have a look at this page again and we reload it, we see that, for example, for our accessor decorator, the property descriptor is this object here, which has the configurable and enumerable and get and set properties. And for the method decorator, our descriptor is this object here, which also has configurable, enumerable, value, and writable. And this is vanilla JavaScript. You have property descriptors in vanilla JavaScript as well. They allow you to define a property in more detail. You can, of course, assign a value to a property, and since we're talking about a method, the value is a function in this case, but you can also control whether it's writable, so if it can be changed after it has been created, after the object has been created, whether it's configurable, so if you can change this configuration and if you can delete this property, and if it's enumerable, which means if it shows up when you loop through your object, for example. And there, for a method, for example, by default, this is set to false, so that if you use a for in loop on an object, this method is not printed as a property. For an accessor, we also got configurable and enumerable, but we got get and set, and there you could, of course, also, for example, return a new descriptor, which assigns a brand new set method, or which suddenly also adds a get functionality. So here in log2 and log3, you can return a new descriptor object in the end, and make that clear to TypeScript that you will do so by returning or by setting the return type to property descriptor. And there you can therefore also set the set keyword, the get keyword, the configurable or the enumerable property, and change how this accessor or method is configured. Now, I don't want to do that here for the accessor. There's nothing interesting I could do with that, and therefore I will not return a property descriptor. But I will actually show you an example with the method decorator where we will return something and where we can build something interesting with the help of decorators. So we can return something on method decorators, and that something should be a descriptor, which allows us to change the method or change the configuration of the method. And this is something I want to do here. Now for that, I will first of all go to the index.html file, and there let's add a button. Click me. A very simple button. In my app.ts file, I now want to make sure that when we click this button, we execute a method on an object. And for that, I will simply add a new class here, first of all, printer. And in there, I want to have a property message, which is just this works, so a simple string stored in there. And then I want to have a show message method in there, where I simply console log this message. So of course, this is kind of a simple dummy class, but nonetheless, this allows me to show you what I want to show you. Let's select the button in the DOM now with document query selector button, and let's add an event listener to it. Now, first of all, I'll add my exclamation mark here to make it clear to TypeScript that this exists, that this will not be null. And then I will add an event listener, a click event listener, and then I want to trigger this show message method here. For that, I will create a new printer here, like this, and then here point at p.showMessage. That's my idea here. Now, if we save that, and we go back to our page, and I click on this button, we get undefined here though. We don't get our message being shown. And the reason for that is that with an event listener, if we point at a function that should be executed, the this keyword inside of that function will not have the same context or reference as it has if we call just p.showMessage. In this case, this would refer to the printer. No, in the scenario here where we use an event listener, this will refer to the target of the event, because add event listener in the end binds this in the function which is to be executed to the target of the event. And of course, I don't want this. Now, a common workaround here would be to use the bind method and bind show message to p, or bind this in show message to p, so that when this executes, this is not referring to what add event listener wants it to refer to, but instead this inside of show message will refer to this p, to this object here again. And therefore now if I reload here and I clear this again, now we see this works. Now that is all default JavaScript. Now we'll build a decorator which we can add to this method, which will automatically bind this to the surrounding class, so to the object this method belongs to every time it's called, no matter where we call it. So for that, above the printer, I'll add a new function and I will name it autobind, because that is in the end what we do, and that will be my decorator, autobind. You can also, of course, use a capital starting character to stay in line with our other namings, but again, you can use either of the two when you define a decorator function. Now this here will be my decorator already, and in there we get a couple of arguments. We get the target, as you learned, and that is any. It is either the prototype of the object we're working with, or it's the constructor function if we would be adding this to a static method, but here it will be the prototype because we will add it to an instance method. Then we have the method name or the property name, but since we add it to a method, we can call this method name, makes more sense. And this is a string or a symbol, or it could also be a number, of course, but here we know we will typically work with strings, so we can also just go with string here, depending on where you plan on adding this decorator and how generic it should be. And last but not least, we get the descriptor here, which will be of type property descriptor, as you learned. So now we got these three arguments, which we also used on log3, which was our method decorator before. Now in autobind, I now want to make sure that we always set the this keyword to the object this method belongs to in the end. Now how can we achieve this? First of all, I have to get access to the method which should be called. And this will be possible with the help of our descriptor, because if you reload the app and you have a look at such a method descriptor down there, you see we got the value property in the descriptor, and that points at the function, because the value of this property is a function in this case. A method is just a property with a function as a value. So the value key holds the original function. Therefore, here we can extract the original method, if we want to call it like this, by accessing descriptor.value. This will give us access to the, well, original method. Next, I will set up a new adjusted descriptor. This will in the end be what we return later. Now this will be an object, and it will be of type property descriptor. Now in this object here, we can add all the things we can add to a property descriptor. I, for example, can set this to configurable true, set enumerable to false so that this does not show up in for-in loops, and now add a getter here. That's new. I add a getter here, which is a method or a property that holds a function, which is the same, so that we can execute some extra logic when users try to access this property, so that we don't just directly execute the value of this property, so the function, but that we can step in and do some extra work before we execute the function. That's the idea here. So I don't add a value property to this descriptor here, I just have a getter. And again, the getter basically is like having a value property with extra logic that runs before the value is returned. Now in here, I want to have my bound function where I can use the original method we extracted up here, and we call bind and bind this. And now the big question, of course, is what does this refer to in here? Keep in mind it's inside of this getter method, so this will refer to whatever is responsible for triggering this getter method. And that's the trick now. The getter method will be triggered by the concrete object to which it belongs. So this inside of the getter method will always refer to the object on which we defined the getter. This will not be overwritten by add event listener because the getter is like an extra layer between our function that's being executed and the object to which it belongs and the event listener. So therefore, this in here will refer to the object on which we originally defined the method. So we can safely bind this for the original method and ensure that now this inside of the original method will also refer to the exact same object. Now I will return the bound function here, and thereafter, outside of this adjusted descriptor, return the adjusted descriptor. So that's our decorator function returning a new descriptor object, and therefore this descriptor object will override the old descriptor. That is what TypeScript will do with it. TypeScript will then replace the old methods descriptor, so the old methods configuration, with this new configuration here, which added this extra getter layer. Now I'm not interested in target and method name here, of course. So to avoid errors, I will name this underscore and this here underscore 2. Again, just to tell TypeScript that I'm not interested in these values, but I need to accept them. And now let's add auto bind to show message here. So here I will add auto bind and make sure that you removed bind down there in the event listener and save this. And now let's have a look at that. Let's click me and you should see this works. If I reload, this works because this is now bound correctly. And just to verify that it's really our decorator that makes the difference here, if I would remove the binding here in my getter in the decorator and I save that, you see that if it is now reloads and we click me, we see undefined again. So it's really this extra getter layer which does its work here, which ensures that this is always bound correctly no matter how you call show message. If we call it like this directly on the object, it will work. If we call it here like this with an event listener, it also works. So you see this works here, which in the end is coming from this show message call. And then you also see it works if I click on the button. So this is one neat example of how you can utilize decorators to build a quite amazing functionality and save you the hassle of manually calling bind everywhere. Instead, you just bind it like this. So now that we saw another nice example for how we can work with decorators, there's one last example which I want to dive into, and that is decorators for validation. For that, at the bottom of the file, I will add yet another new class here, and that could be a course. Now, a course should have a title, which is a string, and maybe a price, which is a number. And then here we have a constructor, where we get both values here. And I'm deliberately not using the shortcut here so that I can easily add property decorators. And then I set this title equal to T and this price equal to P. Now, of course, when we want to instantiate this course, we have to pass in a valid title and a valid price. But one common scenario you might encounter in some applications is that you fetch data, let's say from a web resource, and you get data where you guess you have a couple of courses, let's say, but you don't know for sure. Or another possible scenario, you let users enter the data and you simply want to assign that data and create a new course with the user entered data, and you assume it's right, but you are not guaranteed that it's right, and therefore you want to validate the input. That's the scenario I want to fake here. Let's say in our index.html file, we got a simple form here, and I'll not style it, so it will not be that beautiful, but we have a simple form here with the input of type text and a placeholder of title, course title, and an ID of, let's say, title. And below that, we have another input where the type is also text, but it's the course price and the ID is price. And then we have our button where we submit this. So the button is of type submit. So a very simple form. And as I said, it's not that beautiful if we have a look at it here, but it has everything we need. Now let's hook up a listener to the form here. So here I got my course form, which I can get with document query selector form, and I add the exclamation mark because I know I will get one, so this will not be null. And then on the form we can add an event listener, the submit event listener, and then we get the event object passed in the function which I assign automatically. There I want to call event prevent default so that we don't submit the form and send no HTTP requests. And then we want to extract the data for the title and for the price. So the title can be extracted by reaching out to document query selector, or actually since we assign an ID, get element by ID title. And we know that this will be an HTML input element, so we can use typecasting to let TypeScript know about this. And the price is document get element by ID price, and we can also convert this to an input element. Now actually, therefore, these are the elements, so I will rename the constants to title L and price L. And to get the concrete title, we can now go to title L, access the value property, and to get the price, we can do the same for the price element and get the value there too. And I want to have that as a number, so I add the plus in front of it to convert it to a number. Now, that's that, but now I want to create a new course with that information. So here we have the created course where I can call new course, and I pass in title and price. Now TypeScript accepts this because title will be a string, and since I convert this input to a number, price will be a number. So if I then console log the created course thereafter, we can check if this works. Let's save that, reload, maybe clear the console so that we can clearly see the output, and then add a new course here, JavaScript the complete guide, costs $199, and this seems to work. Now, unfortunately, this also works though if I don't enter anything. If I now click save, we see this course is created. Now, this technically is a valid course, but of course, it's not really valid for our application. We probably want to have a title which is not empty and a price which is greater than 0. So we want to add validation. Now, of course, we can simply add a if check here and check if title trim length is greater than 0, which means it is not empty, and where we also validate the price. But that means that whenever we create a new course, we have to add the validation logic here before we add it. Wouldn't it be nice if the validation logic would be included in the course class with the help of decorators maybe? And that's exactly what I want to do here. Now, I'll only provide a basic idea of how we could implement this. In the next module, I will show you an example package which does this in a way more elaborate way, and which we will then also use there to play around with it a bit. Now, however, here, I want to implement this with my own decorators, and I will add a decorator required here, and I will add another decorator function, which I'll name positive number. So I got two decorators here. And now my idea is that we can add them here to our properties, for example, required in front of title and positive number in front of the price. And TypeScript kind of registers this somewhere. And then we got a third function, validate, to which we can pass an object so any object, and TypeScript then has a look at that object, finds any validation we registered on this class for this object earlier, and applies our validation logic. That's the idea I have here. So this could be part of a third-party library we're exposing to you, and then you just import required positive number and validate to first set up the validators, and then at some point call validate. So for example here, when we created a course, we can call validate and pass in the created course, and if this is not true, so let's say this should return true or false. If this is not true, then we throw an error or show an alert, invalid input, please try again, and only otherwise we continue. So that's my idea, that we can call validate, this returns true or false, true if it's valid, false if it's not valid, and we can therefore use that result. So therefore we get a couple of things to do. We need to make sure that when we add a decorator here, this is somehow stored somewhere. Again, keep in mind, this could be part of our own third-party library. So in there, we could have some kind of storage that stores that for this class and for this title property, for example, we want it to be required. And in validate, we can then check if in this storage for the object we got, for the class the object is based on, we do have a validator registered for the title, for the price, and so on, and we then run our validation logic. That's my idea here. To implement this, I will first of all create an interface, validator config, where I want to configure that storage I have to work with. My idea there is to have a couple of properties, and hence I use this index type notation here, which are basically strings, where the value is yet another object, because this here would be basically the class name for which we want to register some validated properties. And then in the object which we store there, we have the concrete properties of the class that have validators attached to them. So here we have the validatable property, if you want to call it like this, which also will be a string key. And then the value for that should be an array of strings, where basically we have something like required, positive, and so on. So something like that could be added here as a list of validators. Now we can create our registered validators config here, which should be of type validator config, which initially is an empty object, because initially when the app starts, when our third-party library gets loaded, no validators have been registered yet. Well, and then here in our decorators, we want to add something to that registry. Now keep in mind that a property decorator function gets two arguments, the target, which is the prototype of the object the property sits on, or the constructor function if it were a static property, and the property name. These are the two arguments we get here. We don't get the descriptor for properties. Now we can go to our registered validators, and there I want to add a new entry for target.constructor. The prototype of the instance we're working with will have a constructor key which points at the constructor function that was used to create our object. And that therefore will basically be something like course here. So the name of that constructor function in the end can be retrieved from that constructor. Because constructor is a function, we can use the name property, which exists on any function in JavaScript, to get the function name, and this then will be the course name here, for example. So now we register the class name as a key in registered validators, and the value for that then should be another object. So I set this equal to another object here, and in that object I also have a dynamically assigned property where I use my prop name, so the property for which I want to add a validator, as a key. And now the value here is an array of strings, and here I will add required as a string. Now, of course, this is a very naive validator. If we had other validators registered for this property already, I would now override it here. So it would be better to first retrieve any existing validators and then copy them into this array and only add required to that existing array. Again, to save some time here and to just show the general idea, I will have this more naive approach here. With that, we got the required annotation though. Let's now work on the positive number annotation. And of course, that's basically the same. I copy that code, but I set this here to positive or whatever identifier you want to use. And of course, we have to make sure we accept the right arguments. So with that, alone with this, what we added thus far, we register these properties and their validators in our global config when this class is defined. Now we just need to work on the validate function. The validate function should go through all registered validators and then basically run different logic based on which validators it finds. So here, first of all, I want to retrieve the configuration for the concrete object we're dealing with. For that, we need to find out which constructor function the object is based on and then get the validation config or the property validator mappings here, which we set up for that object. So here I'll name this object validators or object validator config maybe, and we reach out to the registered validators here and access a property which should be object.constructor.name. Same logic as before, we access the constructor property, which exists on the prototype of the object, and therefore we can access it directly on the object. Thanks to how JavaScript works, and thanks to the prototype chain, we will then reach out to the prototype if we can't find the constructor property on the object itself, and that will work. And therefore now we got the constructor name, and we find out that, for example, this course here is based on this course class. So we look up any validator configuration we have for the course class. So now we're looking at this object basically. This is now stored in object validator config. Now, of course, we might not find this if we're trying to validate an object for which nothing was registered. So if we don't have any validator config, if we don't find anything there, I want to return true because then this certainly is valid, right? There is nothing to validate, so the object certainly is valid. Otherwise, if we do find it, I want to loop through this inner object here with a for in loop. So with that, I loop through my properties for which I registered validators with const prop in object validator config. This gives me access to all the property names for which we then might have validators. So now, of course, I need to go through all the validators we might have for a property. This always should be an array, even if we only have one validator added. So we can use a for off loop here now and get the concrete validator, which we have for the object validator config for this given property. So now we're getting things like positive or required, which are stored in the validator constant then. And then we could have a switch statement here, or of course call external functions based on which validator we find. But here I'll go with a built-in switch statement, switch on validator, and then basically have different cases. For example, the required case here. Whoops, like this. Here, I want to return true if our property, which we're looking at, so this property on this object, has a non-empty value. So I will return true if object prop is truthy, and to convert this to a real true or false value, we can use the double bang operator. Now here TypeScript complains that it doesn't know whether object has this property, so here we should actually change this to any to get this extra flexibility here. Of course, you could also work on the types here and, for example, also turn your identifiers here into clearly defined types or enums you work with, and maybe also improve the typing here. Though, to be honest, since I want this to work with any object, it is hard to improve this in a way that TypeScript will like it. We could work with generic types, but then again, we would need to kind of restrict ourselves to which objects the generic types should extend and accept therefore. So any might be our best option here to be really flexible and accept a lot of different objects in this validate function. Now back to the switch statement, the required case is one possible case. We also got the positive case which we want to handle. And there I want to return true if the property we're looking at is greater than 0. So if object prop is greater than 0, then this returns true, otherwise this will return false. Now if we don't make it into this for block, or if we somehow have a loop that doesn't loop through anything because we haven't registered any validators, we passed an empty array here or something. So if we make it past this for loop, I will return true as a default as well. And now we return something in all circumstances, and we can use validate. With that, let's see whether it works. If we now save this, and we reload our app here, and I try to submit this, we get an error. Invalid input, please try again. If I enter some text here, JavaScript, the complete guide, I still get this because my number is wrong. If I enter -1 here, we also get this because that's not positive. If I enter a positive number, however, it works. If I have a positive number but the first field is empty, then this also works. So that's something we'll have to work on. So let's find out what the problem is. And to find out, I actually will add a little console log here and log the property we're looking at. We could, of course, also use breakpoints and the developer tools. Now, if I click Save here, you see the first thing which gets validated here is the price, and thereafter we stop. So the price is the first property that gets validated. And that's the interesting thing here. The price is actually the only property that matters here because we return invalidate. That means the first time we find any validator that returns true or false, we immediately return, and we don't care about the other validators. Now, in the false case, this is okay, because if one element is false, if one property is false, is invalid, then we're fine not even looking at the others. But for the true case, it's a problem. If we return true the first time one property meets our expectations, we have a problem. So we should enhance this by having a isValid property here, which initially is true, isValid variable, I mean. And then here we set isValid equal to isValid and this here. And the same down there. Set this equal to this. So that we don't return immediately, instead we just update isValid and we break thereafter to not fall through. The result of that is that in the end, after all these loops, isValid either still is true, but as soon as one of these checks here is false, thanks to how JavaScript works, the overall isValid value will be false, because true combined with false will return false. And then down there we should return isValid. So now we ensure that all properties are checked and not just the first one JavaScript has a look at. This, however, will not be our only problem. We also have a problem here when we have a look at how we register our validator logic. I always override the registered validators for a given class name with a new object. Instead, we should add any existing validators here so that we don't do that. For example, with the spread operator like that, to take any existing key value pairs for that class name on the registered validators and add that first before we add our new one. Also down there, of course. And now with that, if we save this and we go back to our application here, if I have both empty, we fail. If we enter a valid price but we have an invalid title, we fail. If both is valid, we succeed. If we have a valid title but not price, we fail. Also with the negative price. And therefore, this now looks good to me. And this is now a first naive implementation of how such a validator could work with the help of TypeScript decorators. And keep in mind that all of that here, all the decorators, the validate function, and the registry would be hidden away from you. That could be part of a third-party library which you're working on, of course in a more elaborate way then probably, which you share with your end users. And you as an end user would just import these things, add these decorators, and call validate. And you would have a very convenient way of adding validation to your classes then. So we had a look at a lot of decorators, how you work with them, how you can configure them, how you can do stuff with them, what you can do with them. And this hopefully shows you the complexity, but also the power of decorators and how you can think about them, how you can use them. Now, you're not only able to create your own decorators, there also is a rich ecosystem out there of packages and frameworks that rely on decorators. For example, Class Validator. If you search for TS Class Validator, you find a package which basically has a more elaborate implementation of our own custom validation logic we worked on. This package can be added to any project you're working on, and then you can simply import a bunch of decorators, or decorator factories as you can see since we execute them here, add them to your properties with or without some extra configuration, depending on the validator it is. And behind the scenes, this will manage such a registry, you could say, such a configuration object in the end, store your validator setup for the different properties in your different classes, and then give you a validate method, which you also import from the package, which you can execute and pass your object to apply all the validation logic you set up in the class. So it's basically doing what we just did, just with more validators and with all the heavy lifting done for you. But of course, it helps to understand how this generally works, since we built it on our own here in a more naive version. Now, besides this package, of course, we also have Angular, for example. Angular is a framework, which I mentioned earlier already, which heavily relies on decorators, like this component decorator, which allows you to create some, or which allows you to assign some dynamic HTML code, which taps into properties of your classes as well, with a special syntax added by Angular, to then render some dynamic content onto the screen. So here Angular does more than just offer these decorators, but the decorators are a core part of Angular. And last but not least, I also want to show you Nest.js. Nest.js is a server-side JavaScript framework for Node.js, which also heavily utilizes TypeScript, and this also embraces decorators. There you use decorators to define controllers and routes, the methods which users have to use on their HTTP requests to trigger certain functions, and also a lot of other decorators you can use to extract data from incoming requests and so on. So here this framework also again offers all these decorators for you so that you can just add them to your properties, to your methods, to your classes, and add extra functionality, which the framework then in turn also takes into account when it executes your code. So here again, decorators are used for meta programming to add extra configuration, extra logic, which then is taken into account by, in this case, the code of the framework, which executes your code or which works together with your code. And that's it for decorators. This hopefully gives you a good overview of what you can do with decorators, why they can be very helpful, and how they generally work.